Welcome back to the Deep Dive. Today we're looking at a concept from math that always sounds a bit formal, a bit scary. The distributive property.
Yeah, it sounds like something you'd see in a dense textbook. But the source material we're looking at really just boils it down to one sort of action phrase.
Which is?
Pass it out. That's it. Just think, pass it out.
I like that. It's much less intimidating. It sounds less like algebra and more like, I don't know, you're dealing cards.
That's a perfect way to put it. You picture this number standing right outside a set of parentheses.
Okay.
That number is the dealer. And all the terms inside the parentheses, those are the players at the table.
Now, the dealer's job is to make sure everybody gets a card. That's the whole mission here, right? To get rid of the parentheses by dealing everything out.
Exactly. You're expanding the expression so you can actually work with it.
All right, so let's run through the first example from the text. It's 3x plus 4.
Okay, so the 3 is our dealer. Inside, we have two players, the x and the 4.
So the rule is pass it out. The 3 has to multiply every single thing inside.
Right. First, the 3 visits the x. 3 times x gives you 3x.
Simple enough, and this is the crucial part. It doesn't stop there.
It can't stop there. The 3 also has to be passed out to the 4.
And 3 times 4 is 12.
So once you've done that, the parentheses are gone. You're just left with 3x plus 12.
And the text points out that this is where the most common mistake happens. People will multiply the 3 by the x because it's right there, and then just forget the rest.
Yeah, they play favorites. They only deal a card to the first player. But there are no leftovers in math. No favorites. It has to go to everything.
Okay, that first example is pretty clean. But the sources bring up a second one that's designed to be a bit of a trap. It's 5 2x7.
This is where you have to be just a little more careful. The process starts the same, though. You've got the 5 outside.
So you pass the 5 out to the first term, the 2x. 5 times 2x is 10x.
Perfect. But then you hit that minus sign, and that's the trap.
Because it's so easy to just see a 7, right? You think, okay, 5 times 7 is 35, and you write 10 by 35.
And you'd get the right answer, but maybe for the wrong reason. The thing is, in algebra, that sign is sort of glued to the number that comes after it.
So it's not just a 7. It's actually a -7.
Exactly. The term itself is -7. So what you're really doing is multiplying 5 by -7.
Which gives you -35. So the final expression is 10 by 35.
Right. The sign is part of the package deal. If there are 2 terms inside, you multiply twice. If there were 3, you'd multiply 3 times. It's a consistent rule.
So the mental checklist is 1, deal to everyone, and 2, watch the signs.
And once you get that down, it becomes second nature. It's one of those building blocks that makes solving much bigger, messier equations so much easier later on.
It just declutters the whole problem. So to recap, anytime you see a number hugging a set of parentheses, you just tell yourself,
Pass it out.
pass it out to everyone at the table.
And remember, the negative signs are players, too.
You know, thinking about this process, we're passing out a number to expand an expression. It kind of makes you wonder about doing the opposite.
That's the natural next question, isn't it? We've just talked about putting a number into a group.
Meaning you could pull one out.
Well, what would that look like? If you started with something like 3x plus 12, could you work backward and pull a common number out of the group?
Something to think about. Thanks for listening.